If the hydrogen atom is pointed towards you, the traditional rules for assigning R and S nomenclature break down, and that's when most mistakes start to happen. Let me show you one clean move that fixes the problem instantly. Hey there, OChemNinjas. Let's talk about a very specific method for assigning R and S. This is not a universal method. This is a very situational method that works perfectly when the number 4 priority group is pointed towards you on a wedge. This video is part of a series of videos on alternative methods for labeling R and S stereocenters. If you're looking for a universal method for assigning R and S stereocenters that will work every single time, I invented the ARC method, the official OChemNinja method for assigning stereocenter labels that always works. And I have a link to that video down below. The 4 up method only works when 4 is up on a wedge pointed towards you. If number 4 is anywhere else in the molecule, stop. This method won't work. Step 1 is standard. We have to assign the SIP priority. This isn't a video on finding stereocenters or assigning those SIP priorities, but I do have links to those videos in the description below. When we assign the priorities, nitrogen will be priority 1, carbon with the 3 oxygens will be priority 2, carbon with the 3 hydrogens will be priority 3, and the lone hydrogen will be priority number 4. And before we go any further, stop. Check one thing. Is that priority number 4 group on a wedge pointed towards you? If the answer is no, you can stop this method here. This method won't work for that type of molecule. Step number 2 is the core of the 4 up rule. We're going to take this molecule and flip it like a pancake. Being able to rotate and manipulate molecules is a very important skill in organic chemistry. And if you need a refresher on how to do that, I have a series of videos that I'll link to down below. For step 2, we're going to imagine lifting this molecule up and flipping it over like a pancake. Let me go ahead and make a very important point here. We are not changing the molecule. All we're doing is changing our perspective of the molecule. In fact, we can't change the molecule. If we change the molecule, the R and S label might change completely. But think about this for a second. You're sitting there looking at this molecule with the hydrogen clearly pointed towards you on a wedge, right? But from my perspective, behind this big piece of glass, number 4 on the wedge is pointed towards you and away from me. So how do we manipulate the molecule so that you can see it the way I see it? We flip it like a pancake so that you can see the backside of the molecule with number 4 pointed away from you. So let's do that. Let's flip the molecule like a pancake. And when we do that, things that were on the right side of the molecule will end up on the left side of the molecule. And things that were on the left will end up on the right side of the molecule. But watch what happens with the out-of-plane groups. If we have a group that's pointed towards you as the viewer, and we flip that molecule like a pancake, now it's pointed away from you as the viewer. So that hydrogen that's on the wedge right now, when we flip it like a pancake, will flip to be on a dash. And that methyl group that's on the dash will flip and end up on a wedge. The connectivity doesn't change. The priority labels don't change. We haven't changed the molecule, only our viewpoint of the molecule, and now, look what happened. The number 4 priority group is on the dash pointed away from you. Now that number 4 is on the dash pointed away from you, we can bring back our priority numbers, and we can draw our circle from 1 to 2 to 3, ignoring number 4 since it served its purpose. This circle is a counterclockwise circle that makes this an S stereocenter. This works because R and S is an intrinsic property of the 3-dimensional structure of the molecule, not how we put the ink on the page. Let's do 2 more quick examples to lock this in. Let's go through the 4-up method with these 2 molecules. Linalool, the primary fragrance component of lavender, and limonene, the primary fragrance component of citrus. Pause the video, take a second on your own to see if you can use the 4-up method to determine R and S for these molecules. Step 1, assign the SIP priorities. For linalool, the alcohol is priority 1, the alkene is priority 2, the chain is priority 3, and the methyl group is priority 4. Notice there's actually no hydrogen attached to the stereocenter, but priority number 4 is still pointed towards you on the wedge. For limonene, the alkene is priority 1, the chain around this side of the ring is priority 2, this side of the ring is priority 3, and the hidden hydrogen is priority number 4. Next, we do a quick check to see if number 4 is on the wedge pointed towards you. Of course they are, or they wouldn't have made it into this video. Then we can flip the molecule like a pancake. Now that number 4 is on the dash for both molecules, we can bring back our priority labels, and we can draw our circles from 1 to 2 to 3, ignoring number 4. Both of these circles are clockwise circles. That makes both of these stereocenters R stereocenters. The beauty of the 4-up rule is that the pancake flip puts you on the correct side of the molecule. The side of the molecule the traditional R and S rules assume you're viewing the molecule from. One last time, the 4-up rule only works when 4 is up on a wedge pointed towards you as the viewer in the original molecule. If you try to use this 4-up rule with number 4 anywhere else around the stereocenter, it will betray you. And if you find yourself with number 4 anywhere else around the stereocenter, I'll refer you back to the ARC method, the official OChemNinja method for assigning R and S stereocenters. Take a deep breath, ninjas. Labeling RNS stereocenters is manageable, and now you've got another tool in your toolbox.
Thanks for joining us today, Ninjas. Be sure to watch these other videos to level up your ninja training even more. As always, don't forget to like and subscribe.